Hello everyone, my name is Ayush Singh. Today I will be discussing my work on this project, Integrated Retail Analytics for Store Optimization and Demand Forecasting. So the outline are problem statement, then we will go for exploring the three dataset we have, and after we will merge them and then explore it again. We will perform some visualization, then we will have initial data preprocessing, model training, and we have two separate sections for model training. We will discuss it later, and overall insights and our future work. So just let's start. So the objective of our project is to utilize machine learning and data analysis techniques to optimize store performance, forecast demands, and enhance customer experience through segmentation and personalized marketing strategies. And there was some additional information. We can use predictive models for sales forecasting and anomaly detection, and we need to perform segment analysis and market basket insight. So let's just try to look over the three separate data sets we have. So we had featured dataset, sales dataset, and store dataset. So these were the shape of the three datasets. This was data frame third. I just outputted the first 10 rows. Data frame second, data frame first. We saw that the store was common in all the three dataset, and date and holiday was common in data frame 1 and 2. We were trying to understand that there was mismatch in the number of rows and columns. Since in future we will be merging them, I was just trying to explore what is contained in each data set. We look for info for df1, describe. We're also trying to understand how much variations were there in each of the features for each separate data sets. Let me just quickly walk through it. Here we are looking the range of the date we have. We first converted into date and time, data type. Okay, so after exploring our all three separate data frames, we went to merge them. We converted the date to date time object. These were our original shapes, and this was the code to perform the merging. Here we merged df1 and df3. After that, we also merged df2. So this was the shape of the final merge dataset, and we finally saved it. We were saving our result at each and every step so that we can perform the coding part for each separate sections. Okay, from there we went to data exploration of the combined dataset. This was the first 5 rows. Basically, we reordered the rows. Then we have store department. I just wanted to keep the type together. Oh, sorry, date together. Store department and date. So they came together. Okay, after that I saved them again. We have dear option. They were described. We're looking for the missing percentage. We found that the markdown values, markdown columns have a lot of missing values. Minimum was 64 and it went as high as 73%. And we didn't have any duplicates in our dataset. And we also look for the number of unique values for each of the columns, or we can say features. And then we went for like outputting each of the unique values we have for the categorical features or Boolean feature, like date and type, and is for his holiday. We also look all the numerical features we have. After that, I plot the heat map for the correlation matrix. Here we can see that the markdown 4 and markdown 1 are highly correlated. Markdown 1 and markdown 4. It went as high as 0.82. So if we're solving that, we need to drop at least one of them to avoid the problem of multi-collinearity. Okay, after that I went to look for skimpness, and again the same. And the markdown columns have high missing values and they were highly skewed. Also, I found that the weekly sales, our Y level was skewed. So I used log transformation later on to make it look a bit more normal distribution like. Okay, so here we're just trying to visualize all the features we have in a single plot using subplots concept. The skimpness of the store, For a department, for temperature, for the markdowns, we have very high skewness. 5, it went on 8, which is too much. Okay, so just let's now to we went to visualize each of the columns. First, we went for weekly sales. This was the distribution, and we were trying to just zoom it out because it was very small. We basically set a limit for x and y axis. So this was the graph we got. Here you can see there's a it's basically a right skewed, the long tail in the right. After that, we plotted a box plot. Here we kept outliers is equal to true, like showing outliers. This is what not the graph was not like you can say very visible. Like it was difficult to get insights from this, so I just removed the outliers for the next graph. So this was the next graph. Same one, box plot for weekly sales. After that, I tried to use log transform on it. Oh, this was the graph, original weekly sales, and after performing log transform. Oh, this is looking much closer to normal distribution comparatively as compared to the previous one. Okay, we also look for correlation of weekly sales with each separate features. After that, I was trying to understand that what is the correlation between the weekly sales with other features and the log weekly sales with other features. So these two, weekly sales with other features and log weekly sales. We don't see much of the difference. So we can, I think that I was concluding that we can use basically log weekly sales in the future as our labels. We went to plot our store, this was the graph. And we also trying to understand the relation between store and the weekly sales. This was the scatter plot we got. And we also taught plotting hexagon plot. We did in a similar way for all the features we have, like department, temperature, fuel price, CPI, unemployment, and also the categorical feature like okay later on like is holiday. We met a count plot. We also printed it some like this, like percentage and count for each of the two values, like false and true. There was a graph for type ABC. This was the average weekly sales, and we went for plotting the date. This was the weekly sales over date. We can see that there is some kind of annual pattern we can see. This was basically at the end. At the end of the year, we can zoom it out and check it. So we are also trying to like plot some of the markdowns and versus weekly sales. After that, we went for initial data pre-processing. Basically, we had performed log transformation on weekly sales, and we'll again look for missing values, and we're just trying to drop the markdowns and the weekly sales. Instead of weekly sales, we're using log weekly sales. Two reasons. One would be that the skewness part. Another, the correlation was also similar, so this is not much of difference. And this is the encoding part. Is holiday. We like converted true false to int type, and we map from type ABC to integers. And we also saved that file. We then went to model training. We found anomaly detection. We used isolation forest for that, and we got these are the anomalies we got. And after that, we were trying to basically get top 5 anomaly stores, novel stores. We got 38, it was followed by 43, 40, and 44. We were trying to find the root cause for that behavior. We were basically comparing the store 38 anomalies with other stores, like comparison between log weekly sales, temperature, fuel price, CPI, unemployment. And we did the same for department, comparing the department 54, which found anomalous with other departments. After that, we went for customer segmentation. We performed basically clustering. We used k-means for that. We kept the cluster size is equal to n, and three clusters. Three clusters we got. For weekly sales were higher for that. If this is lower weekly sales. We were also trying to understand like what are the values for each clusters. We went to interpret all these things, and we looked at like cluster 2 was high performing and stable. Its ideal profile. Cluster 1 is volatile and underperforming, and its potential need to kept under business review. Later we went on basket market analysis, but when I was trying to implement this code, it took a long time, around 2.5 hours, but the code was not able to complete. So I just went for the sample only 10,000 rows later, like to understand how things work. Provided transaction data. I use transaction encoder. Then I basically use FP growth and association rules. So later we got this. I were difficult to understand the rules, and like we were trying to interpret the results we got here. Here we can see for department 2 to 5, same idea. Left of 2 is using strong singles. These two departments should be positioned together in marketing or store layout. Basically, there was not the column for item, so basically we went for department. Then we went for demand forecasting, and we used our model Sarima for that. Use Sarima, and we basically predicted our next 12 weeks result. So this was the plot we got in our initial data and after the prediction. We can also see like this is looking almost correct. You can see the spikes we got and the starting of the year. We can see the similar kind of result. And also the model training in a different kind of way. Like here we can see I was using LGBM regression. I basically got total RMSE log RMSE as 0.7. So here the features I have defined, I have defined separate features like year, month, week, quarter. I was using classical ML algorithms for this part, second training. I wanted to give it separate, like a kind of additional work, and I got feature importance. You can see this department, store, type, and size were kind of very important, even for linear regression too. Here we got RMSE and R square values. RMSE has 1.89, and our best performing model at that time was random forest. RMSE was 0.46, and the feature importance we got department, store, size were most important features. Okay. So then we were using time series forecast pipeline. So here basically we used first use LGBM regression, and the result work like it was the lowest RMC value I got 0.38. After that I went to try ARIMA for a single. ARIMA is for a single times like time series or sequence. So we get store and department is equal to 1, and this was a plot. And ARIMA's RMSE was 0.17 for store is equal to 1 and department is equal to 1. We did the same using profit model. So this was the plot, and RMSE was 0.14. Okay. So the overall insights and suggestions. So from the basket analysis, we can understand the relation between the items, like one which are frequently bought together. We can make separate plans for them, like put them together and place a combo offers on them, so that when the users or customers come, like they are more likely to buy them together. And from demand forecasting, we can have estimate of possible sales in the future, and if we have that data, we can, let's say if we have high expected sales, we can increase the stock and the number of employees. We can also come with some excited offers to attract more customers. And from the customer segmentation, we are able to group stores together. Let's say we have some underperforming stores, so we can come up with some plans and put in under a business review. And also with high weekly sales, like customer with high weekly sales, they must have like a good customers or high purchasing power there. So we also need to put much effort there. Like this has the capacity to grow a lot more. For the future work, here for market analysis, we use a sample of data, but we should work on a like full data set. Also the item column was missing, so we need to look for that some additional data. For clustering, I only use k is equal to 3 clusters, because we can should look for other possibilities too, like other number of clusters, 4, 5. For mark clustering, we can look for other models to get more sites. And I specifically dropped markdown column here because there was a lot of missing values, around 60% plus, and it was very highly skewed. But we can also try to like look for like if there is uh, actually some randomness or relation between the missing values. Okay, so thank you. That's for this work.